Hi, welcome to our first meeting of the MCES Social Science Data Lab of the semester. My name is Alexander Wenz. I'm happy to welcome you, and I'm co-organizing this event this semester with Dennis Cohen and Andreas Küpfer, who is our student assistant. And the Social Science Data Lab is an event series at the Mannheim Center for European Social Research that provides a platform for tools and methods for the collection, management, analysis, and visualization of data in the social sciences. About our speakers today, we're very happy that our very own Ruben Bach and Andreas Küpfer are with us today. Ruben is a postdoc here at the MCES in the Data and Methods unit, focusing on computational social science. His interests include topics related to big data, in the social sciences, machine learning, causal inference, and survey research. And Andreas is a doctoral researcher at the University of Darmstadt. His interdisciplinary research interests include textless data, applying machine learning technologies, and substantial inference in the field of political communication and political competition. And today's event is the first of a two-part workshop on getting started with Python, a how-to guide for social scientists. And the first part today will focus on the basics of Python, how to install and maintain virtual environments, graphical user interfaces. And Ruben and Andreas will show you a situation where Python may be beneficial for your research, but also when you might decide to go with R instead. The workshop material will be available on the website and on GitHub for you to access now or later as well. Just a final word on logistics. We're recording this live stream in active speaker mode. So we'll post all of this as well on YouTube. And your questions to those of you who are on Zoom will be recorded as well. You may ask your questions if you're on Zoom either by talking or in the Q&A, like directly after, directly now or after at the end. And you can either post your comments in the chat, and then we'll call you up, or you post your questions in the chat, or you send them via direct message directly to us, and then we'll read them out to you. Okay, so Ruben and Andreas, the floor is yours.
Yeah, thank you very much. So we, as Alex just mentioned, we split this up into two parts, and today I will do the majority of the talking, and then next week Andreas will take over. And yeah, the first part is concerned with setting up your environment and everything, and the second part by Andreas is then more hands-on experience and some first very basic machine learning examples in Python. Okay, yeah, so why did we think it would be a good idea to have this talk? Well, if this talk was called Getting Started with R, the answer would be, well, go to our website, download RStudio, and you're done. But unfortunately with Python, it's a little bit more complicated, at least like for us when we navigated Python, it was there way more choices to be made than with R. And so this guide is intended for people who basically have some R experience, some R programming experience, and who want to get some details on how to navigate the Python world. And as an overview, we will briefly talk about why we may want to use Python when we already have a language that many of us probably here already use. Then about virtual environments and packages, how managing those works in Python, about the different GUIs and IDEs, some alternatives to using Python directly, and some additional resources. If you have any questions, feel free to jump in and raise your hand or post your questions to the chat, and I guess Alex or Dennis will read them out. But we're very happy to answer the questions right away. Yeah, full disclosure, I'm not a heavy Python developer or anything. Probably my work is 80% R, 20% Python, but Python is getting more and more. For Andreas, it's probably a bit different.
Yeah, probably. Maybe more the other way around, but still a lot of R also. So yeah.
But we think that this setting makes it even better for you because you're probably in the same situation. You come from the R background, you want to know how Python works, and we can share our experiences with you and have you navigate some of the troubles. Okay, so why would we want to use Python if you already have R? Well, the two languages, the two programs can do very similar things. You can analyze data sets using regression methods, using machine learning methods, some NLP analysis. We can collect data from the web, we can scrape APIs, we can scrape websites, we can visualize data. All of these things can be done with both R and Python. So why would we want to choose another language if there's one that we already have and can use? Well, in some scenarios, Python is simply better suited. And some examples for those situations are when you work with computer scientists. R is a statistical programming language. So a lot of statistical analysis can be done in R. But if you want to program applications, then you probably want to go to Python, which is more of a full programming language. If you want to use state-of-the-art machine learning, deep learning, natural language processing, then at some point you will also turn towards Python because that is where most of the stuff is developed, is implemented at a faster pace than in R. And some of the things aren't even available in R. So if you think about transformer-based natural language processing, you may have heard these things like BERT and all these large language models, then you will have to go to Python. If, say, you're getting your PhD and you already know, well, I want to get a job in the data science industry later on, then being fluent in Python is probably the better choice because from our experience, Python is simply more popular out there. Why? Because all of these state-of-the-art ML models and the like are used in Python. And so Python, if you are also looking at data science jobs. In some scenarios, it makes a lot of sense to just say, well, I do some machine learning, I do some NLP analysis. My work is mostly focused on statistics and regression analysis and the like. Then you may just say, well, there's not really a need to go to Python. You can just say, well, I stick with R. Maybe if I have some time, I look at Python and get some basic understanding. But in those scenarios, and for a lot of researchers, probably that is the default scenario. You can just stick with R and you will be perfectly fine. And in some scenarios, say you really do statistics and regression analysis, then R is definitely the better choice because more of the statistical, much more statistical routines are implemented in R, and it's way easier to use those than in Python. Okay, so say we have decided we want to go start our Python experience, and we have a project where we want to use some more advanced NLP analysis, some neural networks, some deep learning. And we say, well, okay, no, we need to use Python. So how do we get started? A few things that we should know in advance. One very important thing are virtual environments and packages. So how do I set up my Python environment? And other than in R, we usually have a bunch of different programming environments. That is, what does environment mean? We have one kind of isolated installation of Python, and all of the packages that we use, we usually only install into this one isolated environment. Why? Well, we will have some examples now. So some words about Python. Probably most of the stuff I already mentioned. It's a general purpose programming language. There are different versions. Today, you find some Python 2, but most of the stuff is Python 3. If you're getting started with Python today, you will probably just want to use Python 3. When you go on the web and look for tutorials, you sometimes still find like, do I need to use Python 2 or Python 3? If you want to do data science stuff, then probably your default choice is just Python 3. That's it. You can check if Python is already installed. So if you have a Mac or a Linux system, then Python is usually already installed. You would just open up your terminal or command line interface and then type in Python followed by -version to get some idea whether Python is already installed. And whenever you see this little, what's it, special character, is it a $sign? Isn't it dollar? Yeah, right. $sign. That means it's code that is to be run in a terminal or in your CMD if you're on a Windows computer. Okay, so you can check that maybe Python is already installed. If not, one step could be you go to python.org and just download Python and install Python. That's basically it. And if you want to jump in, just feel free at any point. Yeah, so if we now want to download or install Python, usually, well, we start with Python 3, already mentioned that, and then we just use the most recent stable release of Python in your root environment. And same goes for packages. What does a root environment mean? Well, I already talked about these different virtual environments. You have one root environment, which is basically your main Python installation. And if you now want to start a new research project, you would set up a new virtual environment, which contains a completely isolated version of Python. And if you want to install some packages, you install them into this virtual environment. And the idea is that sometimes packages require special versions of Python or special versions of packages, or packages interfere with each other. And for that reason, it's way more common in Python to have these isolated environments, which you can quickly set up and quickly delete and install packages in these isolated environments. Yeah, I already mentioned most of that. It's very easy to switch between virtual environments. It takes just a few seconds to set up a new one, to switch from one to another one. And you can also make sure that your code runs on your collaborators' machines, because you can say, well, this environment, you need this Python version, you need these packages, and then it should work.
And maybe one more thing, like when you want to share your work with or your project with your collaborators, you usually share some file. It is called requirements.txt, and I'm not sure whether it's in there, but somewhere. Everybody can just install all the requirements via this requirements text, and yeah, gets the same environment as you. So yeah.
Okay, so how do we create a new virtual environment? We have Python, we have made sure that Python is installed on our machine. And now we want to install a new virtual environment, and we want to install some packages in this environment. Well, the first step is we need to create it. And there are two different ways. We will walk through both of them, and then talk a little bit about how to use the different approaches and which one you may want to use. First approach is you use what is called venv, or short for virtual environment, which is just a way, like you open your terminal, you open your CMD, and then you use this venv function to just say, create a new virtual environment. Just say Python, which means, well, we want to run some Python code, -m, venv, and then some directory. So say you want to install it into, I don't know, home, users, Ruben, and then my new virtual environment. Then you would put this in place of a directory, and you have some folder which you give a name. And then You've created this new virtual environment. Now, in case if you want to use it, you need to activate it. And the step is very simple. On a Linux or on a Mac, you simply call source and the name of the directory or where you have installed this new virtual environment, followed by /bin/activate. On the Windows machine, it's somewhat different. You can get rid of the source and just call the directory and then scripts activate. And you will then be within this new environment. And you will see in your terminal window that in front of the $, you will now see the name of the virtual environment. So what is here directory would then be, say, my new virtual environment. Yeah.
Could you perhaps step a bit to the side because it's difficult?
Oh, sorry. Yeah.
Thank you.
Okay. And so, well, we created our new virtual environment. We entered the new virtual environment by activating it. Then we do our stuff with this virtual environment. And when we're done, or we want to create a new one, we need to deactivate the environment that we're currently in. And well, very simple, you just, when you see you are in this environment, you simply say deactivate. That's it. And then you're back in your root environment. So whenever you're not in a virtual environment, you are in your root environment, which is like your base installation of Python. And you can install any version of Python from your root installation. So you would just say, well, I want to create a Python environment using 3.10. something. Then you can specify the version, and even if your root environment has a different version, you can install it with a new version. Okay, then if we want to install some packages or libraries, we need to install them in this virtual environment, and usually we don't do this from like our IDE. IDE would be something like RStudio. We need to install it usually through the terminal. So where we create our virtual environments, we also install the packages into this environment on our machine. And for this, we use a tool called pip. Pip is simply, it stands for pip installs packages and is the standard package manager for Python packages. It's also pip3, but if you only use Python 3, then you can skip that. Should be installed with your Python installation, so you don't need to worry about that. And the setup to install some new packages using pip is very simple. Just say Python, again, because you want to use a Python program, -m, ensure pip, upgrade. In case you want to make sure that pip is actually installed. This would be the first line here, but usually you can ignore this because pip would be installed. Then if you want to install a package, you just say pip install and the name of the package. So pip install pandas, for example. Pip install NumPy, pip install whatever. If you want to list the packages that are already installed, so if you install a new clean version of Python, then a bunch of packages are already pre-installed, just like when you use R, the stats or statistics package is already installed, and in Python a few other packages are likewise already installed. You can just call pip list, and it will give you a list of all the packages that are already installed and also the version. So when you require a special version, then you can see, well, do I have the correct version installed in this virtual environment? And as Andreas mentioned earlier, sometimes you see a repository or somebody shares code with you and they have this requirements text file, then you can use it to install the correct version of Python, the correct version of the packages, and the packages that you need. And installation from a requirements file, it's very easy. You just say pip install -r and the name of the file requirements.txt. A note on these virtual environments, you will see that you create a new virtual environment and then you have a folder somewhere on your hard drive which has this name and where a bunch of these packages and all these Python installation files are. And usually you wouldn't change anything manually in this folder. You don't put your data there, you don't put your code there. It's just really your installation of the Python environment, and there's nothing you need to change, and you wouldn't make any manual changes to this folder. It's just for the program. Any questions maybe at this point?
Yeah, I have a question. How exactly can do I have to read the slides with these command prompts when there's this $pip list? What do I have to type into Python so that the command actually works? Because when I type in pip lists into Python, into my environment, it says invalid syntax.
Okay, that's probably because you are in Python, right?
Yes.
Okay, and you would call it while not in Python.
Okay.
So
yeah, actually that's the point. So when you're in your terminal, for example, or in Mannheim, you can call Python and then you can type Python code.
I see. Okay.
But not the other way around.
Okay. So the command would be different in Python itself.
no, so you don't install, you don't use this pip command in Python, you use it in your
okay.
yeah.
Okay.
So instead of saying, well, Python and then some commands, or opening Python and then running your commands, you would just call pip and then install your packages, and then you could go into Python.
I see. Okay, thank you.
Yeah, sorry, but that was actually a very good point. It's a little bit unclear.
One question on Zoom. All this virtual environment setup, does it apply as well when you use Google Colab and like, or that's only when you use it locally?
Yeah, that's a little bit different. We will talk about Google Colab later. Yeah.
So no virtual environments.
Yeah. Actually, when you create a new Google Colab session, then you will have one specific environment, but you don't install, you don't open your Colab session and install a new virtual environment. You would have a separate notebook, which is then clean installation. Okay. Now, earlier I mentioned there are two approaches. One is using this Venv, and the other one is using Conda. And maybe you've heard of Conda or Anaconda already. And Conda, I think this is just copied from the website or maybe from Wikipedia, is a package dependency and environment manager for any language. Well, any language, you can actually also use R within this Conda ecosystem, maybe. If you want to install Conda, it's usually not pre-installed on your system. There are two ways. You can either install Anaconda or Mini Conda. Anaconda is this full, very popular data science programming environment, which comes with many pre-installed packages. And this Anaconda Navigator, we also have a screenshot of that later in the presentation. And then there's this kind of reduced version, Mini Conda, which has a few, some fewer packages pre-installed than Anaconda, and it doesn't have this graphical user interface. But what they both offer is this Conda toolbox, which you can also use to create new virtual environments, manage your virtual environments, install packages, and the like. And you can simply check if Conda is already installed by calling Conda and -version. And yeah, if you want to create a new virtual environment using Conda, the commands would be conda create, then -name, and the name of the new virtual environment. So here, my new virtual environment. And then I already specified with Python version I want to use. So in this case, 3.11. Again, we need to activate it if you want to use this virtual environment. Source activate my new environment, or simply activate my new environment, depending on your operating system. And if you want to deactivate it, then source deactivate or deactivate. So very similar. Yes.
Maybe while using Windows, you need to change the environmental variable path to be able to run Python because Windows can't find it automatically.
Okay. To be honest, I don't know a lot about this path stuff. So.
Yeah. So you can set, like, sometimes you have to like tell Windows where Python is installed, and you can set the path. There is one command. I cannot remember exactly what the command is to set the path, but it's quite easy to set it, like just to show Windows where is Python installed, and then it should work. Yeah.
Okay.
Yeah.
Okay, other questions in the chat? No? Oh. Yeah, we can also, using Conda, see which packages are already installed, Conda list. We can install packages by using Conda install, and then also maybe including the version number of the package that we want to install. We can update packages if you know there's a new release by using Conda update. And in some instances, it may happen that a package is not available through the Conda channels, because Conda is this own data science environment, and they use different channels than the standard packaging channels to install packages. And if you get some kind of error, then what you can do is you can still use pip inside a virtual environment that you created with Conda to install packages from the other, they're called repositories. Yeah. So if you run into troubles, you can always just call pip install, and then there's an example like GVM gradient, light version of a gradient boosting algorithm. Okay. So we know how to install Python, we know how to create these new virtual environments, how to use them, how to install our packages. Now, well, we could just open Python in the terminal and write our code there, but that's probably not how we want to use it. Like, I don't know how many of you use R from a command line interface. So there are some graphical user interfaces and IDEs that we can use. And as I mentioned in the very beginning, there's no one-stop shop solution like RStudio. So we have a variety of options, like we have Google Colab, Jupyter Notebooks, Spider, PyCharm, and a lot of other platforms. And now the question is, well, which one should we use? Well, it depends on your personal preferences. Which one makes maybe sense for my needs and preferences, and so we will walk you through some of the ones that are the most popular and make most sense in our opinion. If we install this Anaconda stuff that I mentioned earlier, remember it's an integrated data science environment that we can use. And I said it installs this Anaconda Navigator graphical user interface. And that is somehow a platform that allows us to manage our virtual environments and to install some of the IDEs. IDE could be something like RStudio, and helps us to work with those. And now this is actually copied just from Wikipedia. The link is when you click on Wikipedia. Anaconda is a distribution of Python and R programming languages for scientific computing, and so on and so on. And the nice thing is it already has a lot of packages and includes this graphical user interface. So how does Anaconda Navigator look? Well, this is just a screenshot I took. If you open your Anaconda Navigator, which is installed when you download and install Anaconda, this is how it will look. So it's just a tool that lets you navigate a few things. When you're just on the home button, then you will see these different applications. And actually there will probably somewhere be RStudio as one of the options for these IDEs. And what you can do is you are usually in a virtual environment or in your root environment. So here I'm in my root environment, and then I can install these different applications or IDEs to work with and use when writing actual code. And when I want to manage my environments, what I can do is I can have, I do not need to use this command line interface terminal stuff. I can simply say, well, I click on create and I create a new environment. I give it a name. I can see which packages are installed within this virtual environment and the like. And so, for example, these are some of the virtual environments that I had installed on my machine. And then I can simply say, well, I think it's somewhere, I think if I click on this play button, then this will activate this virtual environment. Okay. Now, let's say we downloaded Anaconda Navigator and we use it. And now we still need to find our platform to write our actual code. And we want to present a few of those: Spider, PyCharm, and some web-based interactive computing environments like Jupyter Notebook or Jupyter Lab, and Google Colab or Google Collaboratory. One note, unlike in our RStudio, you do not install your packages through these IDEs when you're like in your Jupyter Notebook, or well, you can actually do it in Jupyter Notebook. Well, we'll come back later to that. Say you're in Spider, recall, like I walked you through how we install packages. We need to install them into this virtual environment. And when we then go to our script window, we would simply say, well, load this package. So in R, this install packages, which happens inside RStudio, does not happen inside Spider, for example. Okay, Spider is probably one of the solutions which comes closest to RStudio, Spider and PyCharm also. You have your script viewer here on the left. So there's some code that I downloaded somewhere. And then very nicely, you have this variable or object viewer here on the right, which is usually not included in other IDEs. But if you experience to this, like I want to see what kind of data, which objects I have in currently loaded, then this might be an option. So here I have like two objects, one darks, one X, and I can even click on them and have this like viewer type thing that you may know from RStudio. Then you can have a look at, say, your data, for example. So this is maybe closest to what you know from RStudio, and then the output would be shown in the console down here. So here, for example, I just read some data file, and then I just had a look at it. Okay. So Spider, PyCharm, very similarly, they are more or less solutions similar to RStudio. What you will often see out there is Jupyter Notebooks or Google Colab, and those are somewhat different. They are web-based interactive computing environments. What does it mean, web-based? Well, usually your like the graphical user interface or your the way you interact with the tool is it opens up in your browser as like a web page. So something you call it opens up through localhost, and then it looks like a web page, and you do all of your coding there. And the nice thing is it allows you to combine Markdown with code, with interactive cells. You have a lot of options for exporting and publishing reports. Somewhat more similar to this R Markdown thing. You can even run bash commands. Bash commands means all the stuff that I showed earlier with the $, like pip install packages. you can include those in your notebook cells by including this exclamation mark. So if I want to use bash commands inside my notebook, I would simply include them with this exclamation mark, and then I could run them. And furthermore, there are magics commands, which are usually introduced with a percentage and double percentage, and they give you additional cell functionality. So say you want to include some HTML content in the notebook, or you want to change the way that a cell behaves, that results are shown, then you can explore these magics to explore additional functionality. So how does it look? Well, if you open a Jupyter Notebook, this would be a typical example. In the first line, what we have is we have some very simple and always used example code. We just use print hello world, and then we get the result right under the code cell. We can include some markdown. So here I'm editing some markdown code, and if I execute this cell, then I will see the rendered markdown content. And that allows me to create some nice HTML reports and some PDF reports. If I want to share my results, my notebook, my code with others. As I mentioned, we can also include bash commands by using the exclamation mark, and then the output would look something like what is shown here. Why does it make sense to use Jupyter Notebook? Well, you've already seen some of the stuff, but the interesting things are now, if you want to nicely preview or print out some of the results that our code produces. So here I use pandas library, and then I created pandas data frame, and I call the data frame. If I would do this in a standard script, say in Spider, then I wouldn't get this nicely formatted table. I don't know what would happen if I just call it df in the script.
I think there would be some textual output instead in a console, but yeah. But maybe one more note on Jupyter Notebooks. They're really nice to share outputs, share final notebooks, like when you want to present some results. But it can be quite a mess when you try to collaborate with others via GitHub. So, for example, if two of you push some commits to GitHub on one Jupyter Notebook, there is a high chance that you will get some merge conflicts, because unlike when you compare it to our Markdown notebooks, there is much more information included in some Jupyter Notebook, like how often a cell was executed or some meta information, and GitHub is not able to properly merge some changes into notebooks. So then you should probably go to Google Colab, for example.
And I guess it's also personal preferences. For example, some of the things that I do that don't require external computing power from Google Colab, for example, I write plain scripts. I never enjoyed working with notebooks, but I also don't use Markdown a lot in R. So I guess it's personal preferences. But you will see tons of notebooks when you look for stuff online on Python. Okay. Another example, some code, and I just want to have a look at the plot that was created in the end. This example is just taken from the matplotlib tutorial page. It just shows how nicely output can be integrated with these notebooks. If you have used R Markdown before, well, you know how this works, how this looks. But if you like it, then this is probably a good solution for you. Okay. Now, Google Collaboratory or Google Colab. You've probably seen some Colab stuff, or at least heard about Colab. Colab is very similar to these notebooks. It's a web-based interactive computing environment. And what you will need is, if you want to write your own notebooks in Colab, you will need a Google account, and you will need to log into your Google account. And what you get is, you don't run the code on your local machine, you run it on a somewhat virtual machine that runs on Google hardware. So you don't use your own computer, you just have an interface to a virtual machine that is running somewhere on Google's hardware. So if you worked with virtual machines before, this is somewhat similar to these virtual machines idea. One very nice feature is that it includes free GPU use. And maybe you've always wondered, why do people always talk about this GPU? Why do we need GPU? Like, I have a computer, why can't I run my stuff? You need GPUs when you're running, say, deep learning stuff, neural networks, some natural language processing things that are based on these approaches, because they are usually much more faster if you run them on a GPU than on a CPU. So on your graphics unit than on your standard computing unit. And Google includes for free GPUs that you can use. So when you have some deep learning neural network stuff, then using Colab is a nice way to get around this limitation of maybe not having a powerful GPU on your own personal computer. You can even pay some money and have more powerful hardware available. You can just put a few euros into your account and then charge on as you go, and you can select more powerful devices. You have the same Markdown-based text cells and code cells, magic commands, bash commands. You can even install R kernels. What does it mean, R kernel? Well, you can just install R and then use Colab with R code. So you could do all of your R programming using Colab. That would also work. If you want to include data in your Colab, well, if Colab doesn't run on your own machine, doesn't use the resources from your own machine, but resources that are somewhere on Google's hardware, well, how do you get your data into your Colab? You can sync it with your Google Drive. So you would mount your Google Drive, you put your data into your Google Drive, and then you load the data from your Google Drive into your Colab session, and you write out any results that you want to keep also to your Google Drive. And well, that already brings us to some of the limitations. Maybe you work with data, you use data that is somewhat sensitive, and you can't upload it to Google and your Google Drive, and you don't want Google snooping through your stuff. That is some of the limitations. If you, I don't know, if you collect public Twitter data and you run some NLP analysis, probably this is fine. If you have some sensitive survey data or some other very sensitive big data stuff, then this might not be the best choice. Also, when you share Colab notebooks with others, pay attention. Like, you can share the Colab notebook with others and they can directly work in your notebook, but maybe this is not what you want. If you want to display some results, you can have like some viewer only mode. They can see the code, they can see the results, but they don't get to like mess up your cells and run the cells, because if you run some cells and then you have other cells down there and you don't know which cells were run and who did what and who executed which commands, that can be a bit tricky, especially if you're starting. And so make sure if you're sharing Colab notebooks, like make a copy and share that copy, for example. Okay. Some of the downsides, I already mentioned that: sensitive data, sensitive code. Probably if you're doing data analysis, sensitive code. But this is more for people who develop programs, and stuff that is like maybe patented or I don't know, something like that. But just be aware that maybe you have, if you have very, very sensitive code, you may not want to have a company looking through your stuff. Same goes with sensitive research. If there's anything in there where you think it may not be a good idea to have it run somewhere by some company where you don't understand what happens to the data and the code, maybe just go with another option. Is there a question in the chat?
One question is, to use Colab, do you still need to install Python on your computer?
No. You use Google hardware, and Python is then Python is taken from, you can think of like a computer runs somewhere in Google's offices and everything is set up on those.
The second question is, maybe you mentioned that later, but RStudio also seems to have now Python integrated. Do you have any experience with that? Is that an option or?
We'll come to that later, right? Okay, some other remarks, maybe not downsides, but at least remarks. If you disconnect from a Colab session, you may lose data and results. So when runtime stops, that just means you disconnect from your session. I think after 24 hours, you are automatically disconnected and your runtime stops. So make sure, if you're having some analysis, that you write out the results somewhere, or if you have code that runs for days and you don't write it out, just be aware that this is an issue. And uploaded files, for example, from your Google Drive will be removed when your session is restarted. There's no persistent storage. If you want to write out stuff, as I mentioned, you need to write it out to your Google Drive, for example. Anything?
Yeah, maybe as an alternative to Google Colab, when you need more resources and have sensitive data, sensitive code or research, you can also think about applying for access for BWHPC, which is some kind of cluster provided by the state of Baden-Württemberg, and it also provides a Jupyter Lab environment, so basically Jupyter Notebooks, and you don't have to install Python locally, but still, you have to apply, and you need to queue in for resources on this cluster. But I think it's a good alternative to Google Colab, especially for longer periods of research and for longer jobs which just take longer to finish. Yeah.
And sensitive content. Yeah.
Just to jump in, if you want to know more about using the remote computing services of BWHPC, go to the event list or schedule of the Social Science Data Lab all the way back to March of 2020, and you will find both the slides and a YouTube recording by one of the IT members who works at BWHPC that explains the use of this platform in detail.
Okay. Yeah, some alternatives, and there was already a question in the chat, which we will come to now. How do I get rid of the? Okay. Well, it's supposed to say Reticulate. Maybe you've heard of Reticulate. It's a way to run Python code in RStudio, and actually it's simply an R package. You need to have a mini Conda or Anaconda installation. Recall what we talked about earlier, and management of virtual environments packages works then through Conda. Some advantages: it allows you to easily switch between R and Python code and access objects that you created in Python, say data in R. So you could have one script, one markdown document, and you have some Python code, you create some data, maybe you have Python because the stuff is simply not implemented in R, then you run your analysis, and the data that comes out at the end, you can directly call from within your R session. So that is one of the huge benefits. On the downside, environment and packages need to be managed through Conda. Troubleshooting can be a bit more difficult. And I don't know, my recommendation is if you want to use Python, why not just go through start with Python instead of like trying to sneak it into your code. But there are other people who like to integrate it into R because they want to have everything in one session, directly switch between things. But my personal opinion is if you want to use Python, then use Python and not this hybrid solution. Did that answer the question?
I think so. And I think so in RStudio itself, is that also a new IDE for Python or?
Ah, yeah. Okay. So what is RStudio now?
Posit.
Posit. Yeah. Okay. So I can only say the few things that I read, and I don't know if somebody else in the room knows more about that, but basically RStudio is also capable of running Python kernels now, which allows you to run just any Python script from RStudio. That's how I understand it. But Dennis, do you know?
Didn't work with that, but yeah.
So they say like we want to be a data science environment for not just R users, but also for Python users. I don't know, but go to Posit and check out what they say on the website. It's unfortunately everything I can say. Okay, so Reticulate allows you to have Python code in R. By the way, you can even, another thing that you could do would be, if you have a R Markdown document, you can have Python cells, Python code cells. So like when you have a new code block in your R Markdown document, you have these triple and then R, and you could also have triple and then Python, and then you can just run plain Python code.
And you can also access, like afterwards, you can access Python objects from R and the other way around. So it's somehow connected with each other.
But yeah, usually you will need to install Python, update your packages, install virtual environments using Miniconda or Anaconda or this Conda functionality. Yeah. Since we can run Python code in R, we can also, smart people thought, well, we also want to be able to use R code in Python. So exactly the other way around. So if you say, well, I will immerse myself fully in Python, but there's some R stuff that I need to do, some complex statistical estimators where Python is sometimes not the ideal choice. You can say, well, then I need some R stuff, I do it in Python. So the other way around, instead of Reticulate, is RPy2, which is a Python library that allows you to run R code in Python. We have an example here on the right. So the R code here on the top, this is, if you know R, this looks very familiar. And this would be a translation using the RPy2 package. One downside is you kind of have to translate R functions to call them from Python. That is why this RPy2 example code looks a little bit more complex than the R code itself. Again, this is very basic, very introductory. If you have any specific questions, I can point you to some resources, but that's everything I can tell you from the moment, for the moment. An alternative is you can, just like in Markdown, you can have in your Jupyter Notebook or Google Colab, you can specify cells to behave like an R kernel and to be able to run R code. So what you would do is you use this R magic, recall these magics commands, and say, well, this cell is now an R cell. And then you can write and evaluate, I think, plain standard R code. And you do not need to do this translation. It's still based on the RPy2 package, but this is another way to run R code in Jupyter Notebooks by using this R matching functionality. Okay, yeah, we are almost at the end. A few further notes. Maybe, I don't know if there are any questions. Okay. Then, yeah, naming conventions, or naming in general. So just very basic stuff. Naming is a little bit different than you may recall from R. The name can only consist of characters from 3 groups: digits, letters, and underscores. So you can't use dots. I use a lot of dots in my R code. I don't know why it doesn't work in Python. So probably a good idea to just stick with underscores, for example. A name cannot start with a digit, and a name cannot coincide. This is probably the most important one. A name cannot coincide with one of Python's reserved words, which have special meaning to Python. Examples: false, not, class, finally, is, return. Those words cannot, you can't use those words as names because they are just reserved, they are blocked. Yeah, naming. Now indentation. Maybe you heard, well, you need to indent your code. What is like indentation? Is just you have your code and then you continue code and then you put a few spaces or tabs or whatever in front of, say, the second line. And indentation is very important in Python. In R, it's just like you organize your code because you want it to look nice and organized. In Python, it actually has meaning. And the idea is if you have, for example, a function, then you, if you have a certain block of code, then you need to use this indentation. So here I just specify this statement: if 5 is larger than 2, and then I have this block code print 5 is greater than 2. I need to indent it. And if I have multiple lines of code following this, so you define a function, for example, and you would say def and the name of the function and then colon. That's it. And then everything that goes in the function needs to be indented, and it needs, all of those need to have, they can have 5 spaces, they can have 4 spaces, but all of them need to have the same number of spaces or tabs or whatever you use.
Do those various IDEs have a functionality for auto formatting your code?
Probably, yes.
They do, yeah. Yeah, but you can also like configure your own way of indentation if you want. But you have to configure it, yeah. But you can also.
Okay, but like by default, it's the standard established style guide that you ought to use if you want to.
Yes.
Okay.
Yeah.
There's even I asked some colleague with some scraping code I wrote in Python, and he pointed me to this website where you can just put your code, your very ugly code, and it organizes the code in a nicer fashion for you. That could be awesome.
Yeah, I mean, in RStudio for R code, there's even a shortcut, right? So I think it's just Control-Shift-A. So it's really nice to learn the style guide as you go by simply having the program autocorrect for you.
Yeah. So yeah, the 2 things to remember: indentation is important. Doesn't matter how many characters, but it always needs to be the same number of characters if one block of code. And yeah, here you will actually get a syntax error because there should be some indentation. There is no indentation, and it will give me error. Yeah, then importing functions from packages and calling functions from packages. And you will probably have seen that often you see this stuff like import pandas as PD and then pd.read CSV or something like that. And now the idea is we just want to give you some explanation what all of this means. I will move this window. So there are a few different ways how you can import packages, and depending on how you imported a package, calling functions from the package will behave differently. So standard way would be just say import and then name of the package, like library in R, the name of a package. If I try to call this function read_CSV, which comes from the pandas library, it will give me an error because it says, well, read CSV is not defined, so it doesn't know this function. So what I need to do is I need to say, well, pandas.read CSV. Like in R, you can say you have your package like tidyverse, colon, and then a function. And here you will, if you just say import this function, you will have to use it actually this way. An alternative is, and what you see all the time in code, people import a package and then give it an alternate name. So typical names, for example, pandas is usually PD, NumPy is NP, TensorFlow, GF. Yeah,
It's just some kind of shortcut, actually.
Yeah. And then instead of saying, well, pandas.read CSV, we can just call this alternate name and say pd.read CSV. And that just, yeah, sometimes it makes we know where a function comes from, how it behaves, and it helps us organize our code.
And so we always have to do it this way. I mean, in R, when we have loaded it into the library, then it knows, okay, this function comes from this library, and we don't have to type a function : but in Python, we always have to do it this way.
No, if you import a function this way, yes, but there's another way. What you can do, you can say from the package pandas, import, and then a specific function. You will also often see this, like transformer NLP stuff. You often see, like, I don't know, from transformers import, I don't know, autoencoder or something like that, or whatever the packages are called. And then you can directly call the function. But that only works, like, I have only imported the read CSV function.
Yeah, so you cannot collectively call all the functions, but you
can like import all the functions when you say from pandas import and then an asterisk.
okay.
So that
so
also
like
works.
a placeholder, and
Yes,
okay.
yeah, for all functions in that particular package. Yeah.
Do you know, like, what is good style?
I think for pandas, like, everyone is doing it with PD. But I don't know why. It's just some convention. Everybody's doing like that. I think for smaller packages, it's also, yeah, appropriate to just import all functions that are available without PD or some shortcut. But yeah, I've seen like all different naming conventions somewhere. So yeah, there is no real convention there. Yeah.
Related to that, is there an easy way in Python, if you don't reference the package when you call the function, to find out from which package the function was taken? Because I mean, in R, I can just press F1 and it tells me, yeah, this is from this package. Because if there isn't this function, probably you should always reference the package with a function, right?
I think in IDEs like Spider, you will see like a small window will pop up like this. I don't know what it's called, but you write something, then autocomplete style. Yeah, it will tell you from which package this comes. Maybe I don't know in Colab whether they have similar functions.
There is a similar function, I think, in Colab to see like all the available functions when you start to type something. But yeah, I think that like the best option is to go with some IDE and to use this.
Okay.
And I mean, there are also add-ons like code pilot things which help you auto-complete your code, or tell you how to write your code more efficiently and all these kind of things. Yeah. Okay. Yeah, and that brings us to the end. Some additional resources if you want to know a little bit more about virtual environments and managing them with Conda. If you want to have a look at a Jupyter Notebook tutorial, I think that's a YouTube video. Yes, Reticulate, RPy2. Well, and always DataCamp. If you use DataCamp for R, there's also same amount of stuff on Python. Yeah, those are all links. If you have a look at the slides later on, just click on them. Some of this stuff was actually taken from these resources. Yeah, and that's it from our side. Questions, comments, anything?
I've not heard of DataCamp before.
Oh, okay. Okay.
So is it like, so it's an online learning environment? Is it
Yeah.
free?
No, I think it's $30 per month, but I use it in my teaching a lot because as an instructor, you can say, well, I have this class and you can apply for free access for your course for the duration of the semester. And I used to do that in, like, I taught, I don't know, big data research practicum in sociology undergrad. And I would just apply in the beginning and then tell students who were just learning, were you? Okay. Yeah, and then I would just say, well, you can take some of the tutorials there. And yeah, I don't know who did somebody use that as well in your teaching? Alex, probably.
And maybe some, like, at least somehow free alternative to learn Python, at least in the first, like the first steps in Python, could also be ChatGPT actually, because when you need to, like, you can code in R and you need to convert some basic coding stuff from R to Python, maybe some, I don't know, loops, functions, just to get some hints and to have some code conversion in this ChatGPT. And yeah, you still have to check it for with everything in ChatGPT, but it's some kind of resource which is at least free somehow. Yeah.
Where will we find those slides? On the Social Science Data Lab GitHub? Will you link it there? Or?
Yeah, I will make them available like in half an hour after the session today, but it's not available yet. Yeah.
Okay, and it will be on the GitHub and not sent around via mail?
No, on the official GitHub repo.
Okay, thank you.
Yeah.
One question on virtual environments, whether you can or whether you always have to create them in Python, or you can also do it in an Anaconda.
I mean, so what I've shown in the very beginning was how to like create them using Conda or using Venv, and you could just do the same thing here and click on create, and this would just be the same functionality but without the manual code. So you could click on create and then create a new one, and you could do it through the Anaconda Navigator.
Yeah, question?
Yeah.
Are you familiar with any benchmarking regarding like performance comparing R with Python?
Yeah.
Which one excels?
So from what I've heard when I talk to like data science, computer science people, usually they say Python is more efficient. And
Definitely.
faster.
Yeah. So there are, for example, when you compare reading some large CSVs into R and using pandas, and also another library which is basically pandas, but more performant, then it's like there are huge differences between both programming languages. But it won't make a difference when you, like, I don't know, for example, try to import 10,000 or even 1 million observations, but above that, you should think about going to Python, definitely.
And I think some of the machine learning stuff that I did in the past was much faster in Python. What else? Yeah.
I think reading huge databases is just faster with Python. Also, I don't know, chunking data and then reading every chunk is just more. Yeah, Python is made for it. I think. Yeah, working with not big data probably at this part, but at least huge databases.
One example where Python, from my experience, is less handy than R is if you want to run a regression and you want to have a regression output and look at the coefficients and goodness of fit and all this stuff. That is a little bit more complex to do more coding in Python than in R. In R, it's just you specify LM and then your regression and then summary maybe. And in Python, you need way more code.
Yeah, actually, yeah, Python is more made for prediction and so on. We also take a look at that next week in some Google Colab example. Yeah, and R more for models like inference. Yeah.
And I don't know, for example, Bayesian statistics, how that is implemented in Python. It probably is, and maybe with a focus on prediction, but for inference or explanation focused type of regression modeling using Bayesian statistics, I guess, so be more convenient enough.
I think state of the art would be to use PyStan instead of RStan, so it's called Stan, which is C++ based. So it's all down with the speed of C++.
Okay, so it doesn't make a difference.
Maybe processing large estimates, not the estimation itself.
Other questions, comments? Can I maybe ask who of you has used Python before, who wants to use Python, or who was just, I want to know. So who has used Python? Okay, who wants to use Python? Okay. Okay, yeah.
Can you maybe before we tell us a little bit more about what participants can expect during part 2 next week?
Yes.
Yeah, so what we do next week is going into the code. I will show you some basics in Python, how to write inline loops, and then going into packages like pandas, scikit-learn. Pandas is for like handling data. Scikit-learn is for some basic machine learning models. We will take a look at logistic regression in Python and the random forest, and how we could like implement it, doing some hyperparameter tuning, and just to get used to Python and the syntax. And yeah, that's what we plan to do next week. Yes.
Should we prepare something for that?
No, actually, we will provide a Google Colab notebook, and you can just click on a button on GitHub and you can start to execute code and to work with the code I provide.
Wonderful, thank you.
Yeah.
And there will be a third session where there will probably be a lot of Python code, Christopher Klamm, transformer-based NLP stuff. I guess he will.
March 29th, if I remember.
Yeah. I guess he will have a few examples, which will definitely be fine. Okay.
And that leaves us to thank Ruben and Andreas. We look forward to see you next week again. And thank you all for joining. See you next time.